reason? Because we want to understand how what we were doing relates to the inverse. Because if we understand what the questions were that we were being asked before and how to answer them, it'll make answering the new question a lot easier. Okay? So, sine of 30. Try to think and see if you can do it with a quick sketch or in your head without your circle or your plate. So, sine of 30. Narrow it down to two numbers for me. Root 3 over 2 or 1/2. So then you got to think hard. At 30, which one of those is really the y coordinate? 1/2. Okay, because it's across from it. So 1/2. Okay. And the second question I'm asking, again, could have been on your quiz, the tangent at pi over 6. So first of all, what is pi over 6? Pi over 6 is 30. So I'm asking you a question about the same angle, just in a different way. But this time you have to find the tangent. So you already know the sine is 1/2, or the y coordinate is 1/2. So the tangent is going to equal the y coordinate divided by the x coordinate. What is the x coordinate going to be if it's the y coordinate that was 1/2? Root 3 over 2. Okay? So if we can figure out some stuff, then it kind of fits together. So if we did this like with Nick's method, we'll just call it Nick's method. Like you get a whole method now. Okay? So if we did this with Nick's method and multiplied 2 to the top and the bottom to reduce it, we'd get 1 over rad 3. And then we would get the radical out of the denominator. So we'd get root 3 over 3. Okay? Which is a familiar number and something we would expect with a tangent at a 30 or a 60. All right? Okay, so this is review. This is like what we just did on your quiz. I would give you an angle. So I found the location for you. And your job was to tell me at that location what is the sine, the cosine, the tangent, which had something to do with side lengths. Right? So the questions I'm going to be asking you by the end of today are that I'm going to give you a side length, and I'm going to want you to tell me where that happens on the circle. Like, oh, that happens at 30 degrees. So instead of me asking you what is the sine of 30 degrees, I'm going to ask you what angle has a sine equal to 1/2. And then you're going to think about it kind of in reverse, like, oh, when was the y coordinate 1/2? It was 1/2 at the 30-degree angle. Okay? So knowing this information well will help us. Shelby? Yes, and so then we're going to talk about restrictions that we have to take into consideration and how people look at that. Shelby's right. There would actually be infinitely many answers for that, right? Because not only at 30 degrees does it have a sine of 1/2, it has it right over here at 150, right? Would have that same y coordinate. And then I could just take 30 and add 360 and say, oh, that also happens at 390. And I could take 150 and add 360 and get another place that happens. And I could just keep listing them by keep adding 360 to whatever the answer is, right? So she's right. I could actually make an entire list of places, okay? But we're going to learn how to specify it to 1, okay? All right. So what we have to know about inverses. So first, the general idea, okay? So in the past, this is not in the note guide. Just write this on the side. Sorry. Yeah, sorry. But I think it will help you if we write this before we go into the next part. So we would take the sine of an angle. So an angle would be our input. And what we would then calculate or memorize or know from our unit circle is the side length. Okay? So that's what we were doing. Okay? This was your input. This was what somebody told you. And then this is what you found out. This is your output. Okay? What you told them the result would be. So an inverse is going to change. For an inverse, the input is going to be the side length. And the output, your answer, is going to be an angle. Okay? You can just set it right up there. Thank you. All right? So if someone's asking you an inverse question, you have to know, okay, now my answer is an angle, not a side length. Okay? Notation-wise, does anybody know how we write inverses? You guys remember from Algebra 2? If you had like a function, then the inverse of that function, you use the same letter to know that they were like related to each other. It's x in it, but you put this little like -1 right there to be like, this one's an inverse. It specifically is the inverse of this one that it matches. Okay? And then remember on your calculator, when we were solving triangles back at the beginning, and we had to solve something that looked like let's say we're looking for the sine of some angle, and it was equal to 1/2. Okay? And our job was to figure out the angle. What buttons did we put on the calculator in order to solve for that angle? So what did we do? The inverse sine. And what did it look like on the calculator when you went to push the button? How did you know it was the inverse sine button and not just the sine button? Yeah, because the same little -1. So remember that we would type into our calculator this. Okay? So this notation means inverse. Okay. Also, sometimes, this is really weird, they use the word arc in front of the function. So like arctangent, arcsine, arccosine, whatever. This means the same thing as that, okay? So you got to store these two things in your head that when you see them, you're going to read them as inverse. And what inverse means is someone's already giving you the side length, and your job is to go figure out which angle that happens at, okay? So over here, what this means in general is that you might be asked the inverse sine, and then someone's going to tell you a side length right here. So this is where like the 1/2 or the √3/2 or the √2/2 is now going to be given to you in the problem, and your job is going to be able to be able to answer it with what angle that occurs at. So see how they've switched positions, okay? Before I would give you the angle, you thought about the coordinates, and you told me which side length goes with the sine or the cosine. Now, with this one change in notation, you have to know they are giving you the side length, and your job is to say this is the angle where that happens. Okay? So we have to be able to read these things. And instead of this, they might write that. So this would be the same thing as them saying this. I know, super weird. You would still get out an angle. So these mean exactly the same thing. Okay? That someone's giving us a side length, and we are to tell them where that angle happens. Okay? Is that all right? I'll get more used to it. So first, we're just going to write some things the other way so you can get used to the notation, and then we're going to actually try to figure them out and see all the different ways that people could ask us these kinds of problems. Okay? All right. And in your note guide, I know it doesn't say equal 1/2 right there, but it should. Okay, so you can fix it if you have the note guide. All right, so first we just want to practice rewriting them. So if something says this, the sine of y equals x, there's two variables here, the y and the x. Which one right now represents an angle measurement? Right? Y. Because we take the sine, the cosine, or the tangent of an angle, right? And then our answer to that is a side length. So right now, the way this is written, this is the angle, and this is the side length. Okay. Now, if we rewrote that with inverse notation, okay, then we would still be using sine, but sine inverse. Then the input here, like we talked about, now they should give me the side length as the input, and the output should be the angle. Okay? So if we turned this problem into a problem about sine inverse, x would have to be in here, because you have to take the inverse of a side length, and then the angle would have to be your answer, which would be y in this case. Okay? So this is the same information written in two ways. Okay, we're used to seeing it this way, and now we're adjusting to try and understand how it's also written this other way. Okay? So this might be a little more clear because it has the actual angle and the actual side length. Okay? And this is true information, right? You could think about it on your circle. We just did earlier. The sine of 30 is 1/2. Okay? So how could I rewrite this using inverse sign notation? Ariana? Good. So your quiz that is on this might have this problem on it now. Okay, that's the inverse sine of 1/2, and your answer would be 30. And like Shelby said, how do we really know the answer is 30? We're going to talk about that in just a second. It has to do with mathematicians thought about what you thought about. How do we get everyone to get the same answer? And they kind of made a limited area that you're supposed to choose your answers from. And we'll talk about what that area is for each function. Okay? All right, who can tell me how I could rewrite part C using inverse notation? Ryan? That's okay. Good. Okay? So we're getting the idea of it, that the inputs and outputs are kind of changing location, and you really have to understand what they're asking you, right? Because not only are they going to ask you both ways in one like section of a test or a quiz or something like that, they can actually put them together, which we'll look at later. Okay? All right, so let's talk about what Shelby said. How do you know which one is actually the answer? How do we know the inverse sine of 1/2 is 30 when there actually are two angles that have 1/2 as their sine? Okay, so mathematicians saw what she saw. You don't have to write this part if you don't want to. It's not a big deal. They saw there would be these two places and that you could keep hitting those places over and over again. So what they said is we're going to tell people that they have to pick numbers just in a certain area of the circle so that they don't keep listing all these numbers, and so that when I say inverse sine of 1/2, you guys all think about the same thing that I think about. We can't go pick out like 20 different things, okay? And so what they did is they said, well, let's think about it. We don't want any of this overlapping stuff, and sine has to do with the y-coordinate, right? So all the points here in quadrant 1 have the same y-coordinates as all the points in quadrant 3, right? So we don't want both of those quadrants. We only want one of them. Okay? Then down here, all the points here in quadrant 4 have the same y-coordinates as quadrant 3, okay? So they had to go and narrow it down so that we wouldn't have 1 and 2. We were just going to choose from 1 or 2. So they're going to exclude one of them completely. Okay? And same thing with 3 and 4. So off on the side, you're going to want to write this also. I'll show you which ones they chose. Oh, sorry, I'm stupid. I wanted to do this. Okay. So for sine, and for tangent inverses. Okay. So we already said the sines were the same in 1 and 2 quadrants. And then also in 3 and 4. So let's think about how they picked this. The tangents would be the same where? So it's like y divided by x, right? Which these have the same y coordinates, but when you divide them by x, this one gets a positive tangent and this one gets a negative tangent, right? So 1 and 2 aren't exactly the same. But down here you have a negative divided by a negative, which turns out positive just like this one up here. So in the tangent, like these two are the same. And these two are the same. Okay. So what they wanted to do was pick two quadrants where you could get any sine value or you could get any tangent value. So they basically had to pick either these two, right? Because they have different sines and different tangents. Or they had to pick these two. So what they did is they picked these two. So anytime you answer a question about an inverse sine or an inverse tangent, it has to be an angle in these areas. And then they made it a little more confusing. They wanted the numbers to be in a row. But like if I say, oh, you can choose from 0 to 90, then you can't choose any. And then you can choose from 270 to 360. Those aren't like in a row, right? So what they did is they said, well, let's name it so that it is in a row. How would I describe from here around to here? What can I call this besides 270? Negative, yeah. So they say we're going to go from negative pi over 2 or from negative 90, but they actually usually use radians, okay? To 0, around to positive 90, or positive pi over 2. So normally in this case, when you're looking for an inverse sine, we say that we choose an angle that's between negative pi over 2 and positive pi over 2. So if you are like, yeah, I know, it's like 330. Don't call it 330, okay? Call it negative 30, okay? Or negative pi over 6. I know, kind of sucks, all right? Cosine, they had to change it. I know it sucks they don't all have the same rule. But they can't use these same quadrants for the cosine because all the points in quadrant 1 have the same cosine as the points in quadrant 4, right? Because they would have the same x-coordinate. So we don't want the overlapping ones. We want one of each, okay? So for cosine, we have to pick a different area. So for cosine, in the cosine, quadrants 1 and 4 would have the same x-coordinates because they're on that side, okay? Same side of the x-axis. And quadrants 2 and 3. So this one's at least easier because these are different, so you can just pick from 0 around to here, okay? So from 0 to 180, or in radians, that would be 0 to pi, okay? So when you're doing cosine, you want to choose the angle that's between 0 and pi. Okay. So how you remember this, I don't know. You kind of have to remember it. My high school teacher was like, oh, there's like playing fields, and like sine and tangent only play on these fields over here, okay? And then like cosine only plays in these fields over here. I don't know. Somehow I remembered it. I don't know. Good or not. It's not really like a specific way to remember. You're still remembering the same thing, but I don't know. I guess it worked. I never forgot it, so I don't know. All right, so we have to remember these things so when someone asks us the inverse, we don't start listing every single angle that has that inverse. Instead, we just pick the one that's in one of these areas depending on which function it is. Okay, so that solves your problem, Shelby, okay? So Nick has a method today, and Shelby has the solution to our problem. Shelby has a problem. We'll call this Shelby's dilemma, okay? And then we have Nick's method. All right, so this solves Shelby's dilemma. All right, so a couple different ways we can ask this. This is the way that you would be used to seeing it because this doesn't involve the new notation, right? It involves the stuff you already know. The cosine of some angle equals a side length of 1/2. Okay? But remember, there's another way for me to write this, and I want you to get used to it, so I'm going to rewrite it. This means the angle is equal to the inverse cosine of 1/2. And so when I see this, I need to understand, okay, what this is telling me, that I am supposed to go find the angle that has a cosine of 1/2. Okay? Cosine only plays in these fields, right? Okay? So I'm going to go look for the angle here that has a cosine of 1/2. Cosine is which coordinate? The x or the y coordinate? The x. So I'm looking for the angle that has an x coordinate of 1/2. Now, just knowing that it's 1/2, what kind of angles are you thinking of? 30s or 60s, right? So then I have to think, is it the 30 or is it the 60 where the x coordinate is 1/2? Okay? So if you don't know, think about it. Here at the 30, this would be the shorter one, so this would be 1/2. So at the 60, it's the other way around. So it would definitely be at the 60, right? So the answer to this problem is that x is equal to 60 degrees, or what would I call that in radians, just to get you guys more used to this idea? What is 60 degrees in radians? 3. Okay. So I was finding an angle. Makes sense because of two things. Here, that should be an angle. Okay. Here, this response is asking you for an angle. Okay. So in part B, they've already written it in the form we rewrote it in step 2 here. So they've already got x alone. But you look here, you see this. That's a big red flag. I'm calculating an inverse, which means my answer should be an angle. Okay? They're giving me the side length. Now, this is not a side length we're used to seeing because we don't keep irrational numbers in the denominator. What number is this really? Yeah, this is the same as root 2 over 2. If you weren't sure, get the radical out of the denominator, and you'll see that it's root 2 over 2. Okay, so the minute you see root 2 over 2, 45 degrees pops into your head. Just make sure it's in the realm of what we're doing, okay? Sine and tangent, okay, go between negative 90 and positive 90, or negative pi over 2 and positive pi over 2. So like Skylar said, that's at 45. So my answer is 45 degrees, or what is 45 degrees in radians? Put it over there. Good. Pi over 4? You guys with? No, you're right. Yeah. Your first intuition is right, Matt, and then you're doubting yourself.
Arctan. So
yeah. Okay. I don't know if this makes sense. We're not doing C. Well, it's supposed to be, well, no, here, we're going to do it, but it's supposed to be like this. It's like tic-tac-toe. Switch your X's and your A's. Yeah. All right. So the arctangent of x equals 0. Someone explain to me what I'm looking for. What does that mean? It's written the way it's supposed to be written, but translate what should be going through my head. So I'm using inverse. Skylar's telling me the tangent of x should be what? 0. Okay? Does that make sense? So I'm looking for an angle. Oh, sorry. I think it was right the first time. Sorry. Not an issues. I'm sorry. Not usually my MO. Sorry. Okay. All right. So the inverse tangent of 0 equals x. This is saying we know that the tangent is 0. What is the angle that's happening at? Okay. So tangent only plays over here. Where are the possible places that the tangent would be 0? Like, what should I kind of zoom in on if I'm not sure where the tangent is 0? Is it going to be 0 at 30 degrees? No. Maybe 90? Maybe at 0? Maybe at negative 90? Okay. So this is if I'm unsure. Then let's look at the points in those areas. So this is 0, negative 1. This is 0. And this is 0, 1. All right. Yeah, Matt.
Does arc mean something in this?
It's the same thing as inverse. Yeah. Okay. All right. So think about the tangent at each of these spots. It would be y over x. So here the tangent would look like that. Here it would look like this. And here it would look like this. Which one of those is equivalent to being a tangent that equals 0? Yeah, the one on the x-axis. This is equal to 0, right? These ones are not equal to 0. What are these? Undefined. Okay? So this is where the tangent equals 0, which means I need to list that angle. And remember, I'm supposed to list it between negative 90 and positive 90. So you would call it 0, because 0 is between negative 90 and positive 90. Even though it's the same place as 360, we wouldn't list it as 360 because is 360 between negative 90 and positive 90? No. Okay? So x is going to be 0 degrees or 0 radians. All right, making sense? Kind of the connection. Okay. The unit circle knowledge doesn't change. It's just how we're using it. Okay. All right. So here's where it gets ugly. Okay. So first, I want you to notice that the problems up here don't just ask you one thing, right? They're multi-step problems. You can see the steps. If I add more parentheses, I'd be adding more steps for you to do, right? Okay. So you can see there's multiple calculations you have to do. Some are inverses, some are not. Okay. We're actually going to start with part B. I think part B is easier than part A. Why do you think I would look at it and be more compelled to start here rather than over here? Good. This is a number I know from the unit circle, right? I don't know. Now, that doesn't mean I can't solve this problem. This is going to take more like work instead of just like the facts I already know. So I'll come back to the one that requires more work in a minute. Okay? Now, this is two questions. There's a question here that needs to be answered. And then after that question is answered, you're going to take the cosine of whatever you got as the answer to that question. Okay? Now, the answer to this first question, inverse cosine of root 2 over 2. Are they giving me a side length or an angle? Side length, and my answer should be an angle. Okay? You're right. An angle. And then we're going to take the cosine of the angle, and that makes sense because we're supposed to take sine, cosine, tangents of angles, and then get a side length at the end. Okay? So what is the inverse cosine of root 2 over 2? Got it. Yeah, totally. I just want to go through it once so people can see how to do it if it wasn't cosine and negative cosine, but yeah. All right, so we're going to come back to this point in a minute. It's absolutely correct. But so what is the inverse cosine of root 2 over 2? 45 degrees. If you're like, what the heck is she talking about? Remember, this is asking you a question. Where is the angle that has a cosine of root 2 over 2? Okay? So you would think, okay, angles over here is what I'm looking for. Positive root 2 over 2 is the 45-degree angle, has that as its x-coordinate. Okay? So that's how I know this is 45 degrees. Okay? Now the question is, what is the cosine of 45 degrees? Anybody? Rad 2 over 2. So this brings me to Skylar's point. If you notice, yeah, sorry, Alex.
So why again can't we use like a different angle like 320 degrees? Does that still have an x?
Because if we didn't limit it to certain angles, we could all name different ones. So what they did is they just restricted it and said in cosine, you're only going to list things from 0 to 180. And in sine, you're only going to list it from negative 90 to positive 90. Like a mathematician solved the problem that like Shelby solved, Shelby's dilemma, right? And said we could all list different ones and like we would all technically be right. So in order to solve that problem, they said, okay, we're going to do this when we take inverses. We're going to limit what we're going to look at so we're all talking about the same location with the same number instead of different numbers describing those locations, okay? So like a person put the parameters on it. So I asked you guys what angle had a cosine of root 2 over 2. You told me 45. Then I made you take the cosine of 45, which gave you root 2 over 2. This is kind of a special situation. Now, I did it the long way because I wanted you to be able to do it. What if this said tangent or sine? You could do what we just did, okay? But the fact it's cosine and inverse cosine, Skylar, this is what he was talking about before. What's really going to happen? They're going to cancel each other out, okay? That's why our answer was just root 2 over 2. But the reason I went through the steps is because if I change this to tangent, you could now still do it after seeing the steps instead of just saying, oh, they cancel out. Okay?
So what would happen if it's a tangent?
So if it's a tangent, you would have still done this part, and you still would have got 45, and then it would have been asking you for the tangent at 45, and you would go figure out that number. And it wouldn't have been the same number, root 2 over 2. Okay? It would actually be 1, because the tangent at 45 would be 1. Right. Okay? All right, so what do we do if it's not a place on the unit circle? Let me tell you right now, I can ask you a ton of questions with these because you guys should know everything inside and out, right? Because it has to do with your unit circle. These questions are really, really limiting, okay? I can kind of only ask them in this way, right? Because the inverse sine of some side length is supposed to give me an angle, right? And then I'm supposed to take the tangent of that angle to get my final answer. The problem is, without a calculator, am I going to know exactly what angle this is? No, I only know ones that are 30s, 60s, 45s, or 90s, and is this any of those? No. But, going back to like triangle trig, right? Knowing that there's an angle that has a sine that's 3 over 13, that means this is like the opposite over the hypotenuse, right? So I just sketched my own picture, and I'm going to say, okay, inverse sine of 3 over 13 means the sine is 3 over 13. So here's the angle. Have no idea what its measurement is, okay? But I do know opposite over hypotenuse should work out to be 3 over 13, okay? So if this was the question I asked you on the test, that would be a dumb question for me to ask you. Without a calculator, you can't tell me the answer. You cannot tell me what the angle measurement is without a calculator. But am I asking you for the angle measure? No. The angle measure and understanding what it is part of the problem. But what am I really asking you for? The tangent of that angle. Can I figure out the tangent of this angle without ever knowing the actual angle measurement? How would you get tangent? Opposite over adjacent, so I need this, opposite, over this, adjacent. I don't have the adjacent. Am I done? They were wrong? We can't actually do it? What's going on? Okay, there you go. We can use Pythagorean Theorem in this case and figure out the adjacent. So 13 squared equals 3 squared plus b squared. So b squared is going to equal 160. So b is going to equal whatever the heck the square root of 160 is. We're just going to leave it in simplified radical form if we don't have a calculator, okay? So if I break down 160, I don't know, I get 16 and 10. And 16 is 4 and 4. So there's a perfect square. So I would have 4 rad 10. I'm just going to put that there. All right, so now when I go to calculate the tangent of the angle, even though I don't know what the angle is, I know all the surrounding sides, and I can put opposite over adjacent, which is 3 over 4 rad 10. And this problem's kind of annoying because it's radicals that we have to then simplify, okay? So this is going to be 3 rad 10 over, that's just going to be 10, and 4 times 10 is going to give me 40. The 3 and the 40 don't reduce, so I'm good leaving that as my answer. Okay? So this uses notation, but here we can't find the exact angle. If it's a value we represent from our unit circle, we can find the angle. Okay? All right, so there's no new homework tonight. Just kind of mull over this idea of what the inverse looks like, what it's really asking you to do. And tomorrow we're going to do a bunch of practice stuff in class to make sure you guys can do some on your own. Okay?